All right, so we got a customer who came in with this old wheel hub, and this one is just a sample part. As you can see, the bearing assembly is not on here any longer. This is the damaged part, but it's for reference. So I'm going to bring in one of the new ones here and show you the difference. Okay. So, as you can see, there's significantly more material between the outer edge and the wheel stud than there is on this hub. And that's because this hub is actually too big. It's kind of customizing the purpose on this vehicle. You know, different wheels, different brakes, all these sort of things. So this hub needs to be turned down so that it'll fit inside the brake rotor on the vehicle. So it needs to be the diameter of this one. He brought this in for the sample piece. So the problem that we have is that if it were something simple like this, we could just grab this in the chuck, put it in the forejaw, turn this down. It'd be a simple 15-minute job. Unfortunately, these hub assemblies come with a bearing installed. Okay, now, there's tools for cracking this and taking the bearing off, and just labor. It would just cost the customer so much money if I were to try and pull these bearings off, press them back on, do all this kind of stuff. So I was looking at how I'm going to go about putting this in the lathe. Because while this has a nice surface right here that I can clamp onto very easily, this half spins. Okay? So if I clamped onto here and this is spinning and I'm trying to turn this diameter down, it just isn't going to happen. So the other side, we have a very small lip. There's very little material to hold, and there's a little step in there. So I can't just grab it here and turn it. I can't put a center in here to support the other side because it's just too big for any of the centers that I have. And I've got some fairly large ones, but the cones are just too small. So what we're going to do, I'll go over the lathe and show you this, but we're going to grip it on this side. Luckily, my 6-jaw is only out by like 0.02 of an inch. So that's going to be 1 thou per revolution on this. It's not really going to matter. So I don't need to put this in the forejaw, which is really nice. The problem with putting it in the forejaw is the fact that we have 6 bolts. No matter what orientation you put this in the forejaw, at least one of these bolts needs to be where a jaw is. However, because I have a 6-jaw chuck, the jaws can come in between each of these, and my 6-jaw is relatively accurate. So let me get over to the machine, and we'll show you what we're going to do in order to support this piece so we can turn this diameter off. Okay, so I'm going to turn off the camera, get set up over there, and we'll come back to the solution. Okay, here we are on the 6-jaw, and as you can see, the bolts fall in between each of the jaws. So this was a nice, easy way to go about doing this. But as we come over here, you'll see this is a lot of weight to be hanging out with such a small amount being held here. So we need to bring our tailstock in. So what we're going to do to bring our tailstock in is, again, I don't have a center that fits here. We're going to make a plug. And we're going to bore this plug, we're going to turn this plug down to be the inner diameter here. We're going to have a lip that'll register on the surface here, and of course a divot for our center to go into, and that'll just be pressured against there with light tailstock pressure, just enough to hold it against the chuck. That way this is supported, we don't have to worry about it slipping. So I'm going to go ahead and take this out. I just want to throw it in as an example to show you what we're going to do, and we'll get over and we'll start turning this into the piece to support. Okay, so what we've got to do to make this plug is go ahead and measure this diameter so we know what to turn down our aluminum slug to. So we'll get our telescoping gauges here. Okay. I don't like the way that felt. We'll do that again. That felt a little loose going back in. There we go. And our mic. See where we are. Get this little latch. And sorry, I can't read that on the camera, guys. I got to bring that up near my eyes so I can see what's going on here. Okay, that's funny. It is 555 on the inside, 0.555. So we're going to go ahead and turn that and test fit the piece. So we'll get back over to the lathe here and get that piece knocked out. And technically, we don't need to face this entire thing, but we're going to do it anyway. We would really only need to face as far in as our inner diameter, just to be sure we had nothing interfering. But I like it. All right, now we'll go ahead and just turn a diameter to get something round to start with. All right, now we'll take a measurement and punch that in our DRO. And you'll notice I'm using my calipers here. This is accurate enough for what we need to do here. Okay, 2.2125 in the DRO that goes. Okay, and we got to take that down to 550. We'll just double check our measurement while we're over here. Sorry, I keep saying 550. I'm ignoring the inch. It's an inch 5.5. That's the actual measurement. Yes, I know it is an inch. I just haven't said it out loud. Really probably should do that for the film because you guys don't know what's in my head. Yep, 155 is what we got to go to. Okay. All right, so let's go ahead and we'll take 100 thou off of here. Now getting a little aluminum buildup. Better put some oil on that thing. Making those heavy cuts like that builds up a lot of heat, and sometimes you can get aluminum fusing to the carbide insert. Do another 100. We're just keep chewing away 100 at a time until we get close. 50 thou depth of cut, by the way. 100 on the diameter. We're at 1.9, going to 1.8. All right, we'll take a measurement, see where we are. Okay, 1.6 on the nose. Okay, so we got to go 1.55, so we're going to go 1.57, and then sneak up on it. I actually think it's 1.54 for the internal fit, but we're going to take that little by little so we get a nice snug fit. So 1.57 coming up. 9, 8, and dialing down to 7. There we go. It's close, it's not exact, because we're going to sneak in on it. Take another measurement. Okay, yeah, 1.57. Okay, that part's a little hot. I mean, I can touch it, but it's warm, and we want to have a nice snug fit. So I'm going to give this a few minutes to cool off before we come back and make the final cuts, just to be sure we don't have any expansion going on. It really shouldn't be too bad. I can hold it, you know, so we're probably not even that warm, but why not? So I'm going to pause this, and we'll come back when that cools down a bit and make a couple final cuts. All right, we're at 1.57 here. The part's cooled off. I went and remeasured our internal, and we're 1.552 over there. So we're going to shoot for 1.55 here, and that should be plenty accurate. It's going to give us less than a thou run out on either side. So pretty good for, you know, a wheel hub, and the part that we're taking off is external. It just has to fit within the brake rotor, so we're good. Okay, so we're going to take this down to 1.56, and then we're going to sneak up on it. And because we're getting so close, I don't want to take all my material away, so I'm going to do just this little bit until I get it exactly where I want it, and then we'll make the full cut. Yeah, 1.56, exactly what I wanted. I'll leave a couple thou on there, just for testing purposes. One 5.51, that does it. All right, we're going to turn it down, bring our hub over, test the fit in case we got to skim anything off of here. All right, now just make sure we're not going to have a burr interfering. And we're going to wipe this part down to be sure there's nothing on there, because this should be pretty close. All right, let me go ahead and reposition the camera so you can see the test fit here. Woo, sorry if you got dizzy. So here's our new hub with that internal dimension that was 155, whatever I said, 4, 2. There we go. Nice snug fit, no rocking. Perfect. We'll go ahead and cut the flange on that flat. Then we got one more operation to do. And all we're doing here is cutting that flange and drawing back to have a flat edge. Okay, and we've got one more operation here. So right now, we have a very nice concentric circle where we'll be able to find the center. But if I were to take this out and turn it around to drill the center on the opposite side, which is where we're going to need our center to go, we're basically not going to be concentric anymore. So we're going to drill a through hole all the way through here. And that through hole will be where the tip of the center rests. So we're going to go grab a drill bit and go ahead and get this marked out and drilled. So I'll be right back. All right, here we go. We've got a 5/16 drill bit. Not that that really matters so much, but we wanted to have a large enough diameter that when we put the center on the opposite side, that we're sure, sorry, I just want to make sure that wasn't a burr there, it's on the outside, but we're sure that there's enough concentric material to get a good bite on the center, if you will. So. When I'm in aluminum, I like to back up frequently. Pretty much the moment I see chips forming at the hole, it really reduces the heat buildup and reduces the amount of weld that you get from the aluminum trying to bond to your drill bit. So it seems like a lot of back and forth sometimes, but in the end it's actually a lot faster. Okay, now we're going to take our part and we're going to flip it over. And we're just going to face the other side. That way, when the center drill sits in here, we know that that hole isn't at some slight angle or anything, because we have some very nice, concentric and perpendicular surfaces to reference now. So let's go ahead and get this flipped. Hate it when that happens. Oh, and of course the cross handle fell out and is behind the lathe now. I'll get that in a little bit. I'll just use a different handle for the moment. Nice little deburring tool, just to be sure the edge doesn't have anything on it. Deburr the outer edge. Okay, there we go. And I got one more cleanup operation. I intentionally waited till the end to do this just because I didn't have enough room when it was in the chuck a moment ago in order to do that. We're just going to deburr that rough edge right there. Actually, you know what I'm going to do? I'm just going to take the whole thing right off and then I'll deburr it just so I got a pretty part. So we'll get up to the jaws, come back a little bit. There we go. This is purely cosmetic, has like zero function here. And now I'm going to flip it and do the deburr on that freshly cut side. There we go, one spacer. So I'm going to shut the camera off and once again reset and come back for the next step. And that'll be actually with the parts in the lathe and turning down the diameter. Okay, here we are with the hub assembly in the 6 jaw as we had shown earlier with the bolts, you know, basically spaced around between the jaws. We're going to roll over here and we're going to put our new block that we just made right in there. It's a nice snug fit, no wiggle, no anything. That's perfect. So let me get this out of the way and we'll bring our tailstock in and then we'll be able to start turning down this outer diameter. So here we go. Lock that. A little moderate pressure on the tailstock, not a lot. You just want to hold it in place. Okay, now that we've got that, we're going to go in neutral, and I'm just going to check to make sure that we're still square. Let me get this out of here and find some place to put this. Got so much junk in the way. Swarf all over the place. Okay. We got that dialed in within a couple thou, just using the 6 jaw, so that was pretty nice. I was happy to see that. Since using the 4 jaw was going to be excessively complicated. Bring that over and just give us a spin. Yeah, we're bouncing +1, -1. All right, good, good, good. So we're nice and square there. Let's go ahead and check here. Be sure nothing's shifted on this piece. Got a few more thou there, about 2 thou extra, so I think we're good. All right, here we go. Let's go ahead and put the lathe in gear and make our first pass, enter the DRO, et cetera, et cetera. So. I bumped my e-stop. Ooh, gotta be careful of them spinning parts, that's for sure. Okay, just a nice light cut to start with. Okay. That's some hard stuff, that's for sure. Okay, everybody, I started doing those wheel hubs, and they're on the bench right back here. And, you know, I started showing the machining on them and the setup, and everything was going great, except when I got over here, I had to run the coolant on here. Those hubs were really hard. That steel was a lot harder than I thought it would be. So running the coolant, great, it did a good job, but my camera got covered in coolant. I didn't realize it at the time. And there's probably some coolant footage out there. If I've got it, I'll load it just so you guys can see it. It was a mess. So this poor little camera, I'm glad that it's a little GoPro that I was using here, and I'm glad they're waterproof. I hope they're coolant proof, so we'll find out. So I didn't get a lot of the machining in there, but I did get the overall process. So I really hope you enjoyed it. It was more about the setup than it was turning down a diameter anyway. So I hope you guys found some benefit in that. Well, folks, here we are, roughly 90 minutes later, and only one insert needed. So that was pretty good. This one was the one I started with. It was almost completely used up. I'd used 3 of the 4 corners. 4th corner was halfway, so I had to switch inserts halfway through. But either way, no big deal. Got these up and mounted. Our aluminum insert in the rear here worked great, kept them nice and concentric. Maybe a 2 thou run out total, so that worked out really, really good. So customer's on his way, in and out same day, 90-minute job. So really like it. It came out really well. Pleased with how it worked. It was a little tricky getting that mounted, took a little thinking, but it mounted up nice and solid that way. I liked it. That 6 jaw dialed in nicely. I was able to tap them to be level and plumb. So that was just a real successful job. So I'll go over some of the things I had considered. And what I had considered, this is a junk part. I was going to press out these studs and basically invert it on top of one of the good parts and use this in the 6 jaw and basically bolt them together. Well, that would have been okay, and I could have dialed that in the 4 jaw even, but I could have dialed that in the 4 jaw or the 6 jaw, bolted these together, but I still would have needed to make a sleeve for between here and here because bolts are just not accurate. It would have moved all over the place. So I would have had to sleeve that, and then I still would have had to put the aluminum insert on the back side to support that whole big long assembly in the lathe. So the more I thought about it, it just didn't seem worthwhile to even use this for anything. The other consideration I had was I could have pressed out all of these studs, mounted it in the lathe nice and easily, regardless of 4 jaw, 6 jaw, anything. And gotten a nice grip on it, would have been good, but then I had to press all the studs back in again, would have just been a headache. So after the consideration that I went through, worked out pretty good. Was able to grip it on here and use that aluminum spacer to support the whole thing and turn them down. So there you have it. A little last minute job. I thought I'd make a nice video. And if you got any questions, just please go ahead and ask them down below, and I try to answer as many as I possibly can. Once again, thank you for watching. Thank you for, if you've liked my channel, I appreciate it. It really does go a long way to like and subscribe and hit the notification bell. That makes a huge difference in the YouTube algorithm. It really does. Again, though, hope you enjoyed it. Have a great evening.